on. The second problem we have is 6 times the quantity y squared plus 4 minus 8. So we're going to distribute the 6 through the quantity. So we'll distribute it to the y squared, and we'll also distribute it to the 4. 6 times y squared is just going to give you 6y squared. 6 times 4 is 24. And that's as far as you distribute it, because it's just multiplied times the quantity. Then we bring down our minus 8, and we look for like terms. Notice that we have a y squared. So the 6y squared, that's the only y squared term that we have here. So we're going to leave that alone. And we'll just bring it down, 6y squared. And then next we have 24 minus 8. And does somebody want to give me the answer for that?
$16.
Thank you. Good job, Mike. So then we get 6y squared plus 16. All right, any questions on the first 2 warm-ups? And the next one for the warm-up is we just have a quick little word problem. And it's an old word problem because I don't think we really have DVDs or CDs anymore. But it says that you bought 3 DVDs for $22 each and 2 CDs for $16 each. Write and simplify an expression for the total cost. Okay, so the first thing is you're going to have the number of DVDs is going to be, we'll just put D for DVDs. So those were $22 each. So it'd be 22 times D for DVDs. Plus, now we have the CDs. CDs are $16 a piece. So we'll use C for CDs. And then if we put that together, that's going to add up to our total cost. You can put T, you can write total here. I'll just use T. Now we're going to go ahead and plug in, just like we did last section. We have 3 DVDs plus 2 CDs. So if we look at this, and that's going to equal your total. 22 times 3 is going to give us 66. 16 times 2 is going to give us 32. And then we add up. Can somebody tell me what our final cost is going to be?
98.
Good. So if you put your total cost is going to equal $98. That's it. Any questions on the first 3 warm-ups? So now we have a couple of definitions here, and the definitions are kind of terms that you used already. So I'm going to erase this just so we can have a little bit of room. The first one says term. So if we look up to the example above, there it says 22D plus 16C equals T. All these are terms. The proper definition for a term is, would you say parts that can be added together, Ms. Kane?
Yeah, that sounds good. Yep. Parts of an expression that can be added together.
Perfect.
Just even parts of an expression. Let's just keep it like that.
I like that way better. So terms, you can just think parts of an expression. So if you look at example 2 above, we had our final answer was 6y squared plus 16. Well, 6y squared is a term and 16 is a term. Each of these parts are a term. Everything that goes into expression is a term. A coefficient is going to be what's in front of a variable. And the proper definition would be the number would you say in front or times a variable? In
No,
front?
yep, number in front of a variable. Keep it easy.
I like it. I apologize about my writing.
Looks a little rough today, Mr. King.
So I just got this new iPad cover. Look at this. Real fancy, real good. $8 off of Amazon. So now I'm trying to write on a slant. I'm used to
Oh,
writing on the desk. Now I'm trying to switch it up a little bit. And I apologize to the first class. You're the guinea pig. Okay, like terms are just expressions that have the same variable with matching exponents. So we could say that the variable is matching or matching exponents. How do you want to say that one?
I liked how you said same variable, same exponent.
Excellent. Oh, it's getting bad. I apologize. I'm gonna put it flat. And then we'll talk about these in a second. I think when we look at examples, it's pretty easy to see. But these are just terms that we'll be using all throughout Algebra 2, these words. They'll just become second part of your vocabulary. And then a constant term is just a number without a variable. So if you look at example 2, the 6 is the coefficient to the y squared, and then the constant term is the 16. Any questions over the definitions?
And as Mr. King said, once you see a couple of examples, it'll make more sense putting numbers to those vocab words up above.
Good. Now, everything here on example 1, it says identify the terms in expression. If we remember terms, a term is any part of an expression. So we have how many terms are in this expression? Can somebody tell me just the number of terms we have?
3.
3, absolutely. Now, when we write, this is really important thing for this section, is when we rewrite or combine or simplify an expression, you always want to use the highest power term first, and then the constant terms will always be last. So when we look here, we have a negative 11, that's one part. We have a negative 7x, that's 2 terms, and then we have a negative 2x squared, that's 3 terms. If we were going to rewrite this, which term would we rewrite first? Which one has the highest
Negative
power?
2x squared.
Awesome. So the first one we write is negative 2x squared. And then just because it says identify, I'm just going to put a comma here. The next one would be what? Next term we would use?
Negative 7x.
Awesome. And then lastly would be your constant term, which is negative 11. So when we look at example 2, it says identify the coefficient and like terms in the expression. Okay. Well, so coefficient is any number that's in front of a variable. So when we look here, our coefficients, I'm going to put right underneath where it says coefficients. We have a 1 that's in front of our x squared. Put a little time symbol there. The other one we have is a -7 that's in front of our x. The other one we have is a -3 that's in front of our x squared. So all on this left side, our coefficients are a 1, a -7, and a -3. The second part of this question says, combine the like terms in the expression. The like terms mean that they have the same variables that have the same powers. So for example, we have a 1x squared, and that could be combined with the other x squared, which has a -3 in front of it. So 1x squared minus 3x squared gives us what? Somebody give us the answer here. Hey, oh, good, Mike. -2. Good. So you're going to end up with -2 x squared. Next, we look for our x. We only have a -7x. There's no other x's on here. So that -7x we could just bring down. Lastly, we look for constant terms, which we have 2 of them. If you look, we have a +5, and we also have a -10. 5 minus 10 is going to give us a -5 as our answer. So when we simplify this, you end up with -2x minus, sorry, -2x squared minus 7x minus 5. Are there questions on that? Ms. Kane, you want me to go over a couple of these example 3s?
Yeah, yep.
Okay, so we're just going to work through. I'm going to call on you, and if you want to be ready to help me out with the answer. Ray, on the first one, A there, 5x plus 9x. We only have the 2 terms, but we can combine them because they're both x. What's 5x plus 9x?
14x
squared. Now you have to be careful there.
It's just x.
Just x, because we're not multiplying. If we multiplied those, you would have an x squared, but just adding, you just keep the x. You had adding or subtraction, you keep the variables the same, multiplying, dividing, will change the power. Good. The next one, I'll go ahead and help through this. We have a 2x squared, and we're going to look for our like terms, which is another one of our vocab words. So we have 2x squared, and then we have minus an x squared. 2x squared minus x squared will leave us with 1x squared, or just x squared. And then next we have our x's. We have a +3x and a +6x. Haley, what's 3x and 6x? What are we left with there?
9x.
Awesome. And that's our simplified expression, x squared plus 9x. You notice in part C that we have 2 different variables altogether. We now have an x, and then we have a y. It doesn't not matter if you put the x first or the y first. That's totally up to you. If you want to go alphabetical, you could. If you want to use the y first because it comes first, mathematically it doesn't matter, but those 2 would be combined. So since we'll just start with the 4y, and then we have a -12y. So -12 plus 4y, or 4y minus 12y. What do we get there?
-8.
-8.
Awesome. -8y. And then we have our x's. We have a -7x and a +3x. 3 minus 7 will give us -4. You get the answer of negative 4x. There are no constant terms on this problem. All right, I'll do the next three rather quickly to give you guys a little more time. So on D, we have 7x and 4x. They're the same variable. They both have x's. They're both to the first power, so we can combine them. 7 plus 4 gives us 11, and then x, since we're adding. Part E, we have x squared and we have x's. So we're going to look at our x squareds, which is a 3x squared with a negative x squared. That'd be just like having a negative 1 in front of there. So 3x squared minus 1x squared is going to give us 2x squared. And then lastly, we look at our x's. We have a negative 4x plus 9x. 9x minus 4x gives us a positive 5x. Questions on D or E? And then lastly, F is just like C. We're going to look at our y's and we're going to look at our x's. We have a 6y that we can combine with the negative 9y. 6 minus 9. Anybody? What do we get for our y's here?
Negative 3.
Awesome. So you get negative 3y, and then what do we get for our x?
Negative 5.
In this case, we have negative 9 minus 4 more. So that would end up giving us a negative 13x. Questions on those? Okay, if you look at example 4, it's very similar to example 3, except we're just adding one extra step. In this case, we're going to distribute, and then we're going to simplify.
Mr. King, if you just want to do A and B, and then we'll give them some time to work, does that sound okay?
Love it.
Okay, good.
So I'll get through them quick so we have some time there. So if we look at the terms, we have 12 minus 5 times the quantity, x minus 1. What you need to do first is we're going to distribute through. Bring down to 12. 12, so now we distribute through to negative 5. Negative 5 times x gives us negative 5x. Negative 5 times negative 1. Negative and negative give us a positive. 5 times 1 gives us a 5. Now here's where it's really important when we write down terms. You always write your highest variable degree first and then your constants last. So you notice here we only have one variable. That's the negative 5x. So we could actually take that and bring it down. And now we're going to combine our constant terms, which are the 12 and the 5. 12 plus 5, 17. Questions on RA? So I'll go over to part B. We're going to have two areas we're going to distribute. We're going to distribute the 4, and then we're also going to distribute the 3. 4 times 6, 24. 4 times negative x gives us negative 4x. 3 times x gives us a positive 3x. And lastly, 3 times negative 8 gives us a negative 24. Now you're going to combine your like terms. Our like terms here, we're going to look at our x. We have a negative 4x, and then we also have a positive 3x. Negative 4x plus 3x, or 3x minus 4x, will give us a negative 1x, or just a negative x. Remember, you never have to write a 1 in front of a variable. And then lastly, 24 minus 24, what does that give us? Anybody?
Zero.
0. So we're done. Negative x is your answer on that one. All right, Ms. Kane, you want to take it over?
Yep.
All right.
Okay, so a little reminder. You got to see some problems today with combining like terms. When you're combining like terms, you're not moving things, you're combining the numbers in front as they are listed, and use your calculator. So if you have a -3 and a -7, you add them and you get -10. So you're just combining them as they are listed, those coefficients, the numbers in front of x. Your homework today, the first few problems are just listing the like terms. The second group of problems are just listing the terms and the coefficients. So you might need to refer to those definitions of the vocabulary words that we went over at the first part of class. And then there's actually 9 problems here that you're going to combine like terms. So a lot of it is just like listing by using vocab words. And then the second part of the homework is really working through the problems. I'm going to reiterate this. Please make sure that you write the original problem and you show work. You do not get credit for work or for problems that do not have supporting work. So a lot of you are handing me in answers. You don't get any credit for answers in math class. You have to have work in order to get credit. Also write the original problem down so that you can kind of see where you started and where you ended in it. And you can do this on a separate piece of paper. You could do this on a screen in Notability. It's up to you how you want to do your work. But please make sure you have work supporting your answers. Questions? So you have about 15 minutes. Again, you can choose to stay on the Zoom with us and work through the problems, and then we're here to answer your questions. Or you can get off the Zoom and just work through them on your own. But you still have class time to get some of this homework done. And it should not take you very long to do this assignment. But again, please make sure you're showing some type of work. Does anyone have questions? All right, awesome. So thanks for joining us today. We will be here to answer questions if you want to hang around. Otherwise, we'll see you tomorrow.
Thank you.
You're welcome. Have a good one.